Hi folks, Geek here. Unfortunately, no one noticed that the microphone was turned off until about the 9-minute 7-second mark. So if you go to the 9-minute 7-second mark, audio will resume. Sorry for the inconvenience.
It wasn't even turned on.
There you go.
Oh well, I guess I got to restart, guys. No, never mind. Yeah, I'll just wait for my microphone to get reset. No, it's not a problem. I mean, there's only 5 people in here. I'm not really worried about the recording. I'm worried about you guys. I want you to have the takeaway, not the guys on the internet. If they want to come see my talk somewhere else, I can do that. I should have been here. All right. So as I was saying before, we've gone through the .NET journey, and in the beginning there was ASP.NET, and now we magically have ASP.NET Core. And in order to get there, we had to go through the rigors of hiking up the mountain of closed-source software and then exposing ourselves to the glorious sun of open source. And now we have a new framework. And this framework, it has a new HTTP pipeline. It has ways of directly integrating into it at such a deep level that you can just make it do whatever you want. You can take ASP.NET Core and just make it do the most imaginable things. As long as you communicate over HTTP or WebSockets or standard protocols, you will be fine. In ASP.NET Core, it's built with the latest and greatest C# features. .NET Framework is locked to versions of Windows. You have versions of Windows that come out in the spring and that come out in the fall. That's when you get your revisions of that. But .NET Core, it comes out every quarter. It's coming out constantly. They have constant release schedules, constantly inventing new things. That was one of the major driving factors for the rewrite. The next thing you have is built-in dependency injection. Now, I know there are some experienced people in our audience, so I will say this. Dependency injection is the ability to basically take bits of code and give them the ability to go into your other code in a decoupled manner. That way, you can take whatever dependency you have and just inject it into that code and not have to worry about how you actually get that process done. It's like magic. So by having this magic in there, you have a unified model of actually putting in dependencies. If you need to swap things in the back end, then you can just take a new implementation of that and put it into your existing code and just never breaks. Or you hope it never breaks if you have tests. So the next thing is it's VM independent. It'll run on .NET Framework, .NET Core Mono. We went over that. The next thing is that it's host independent. So ASP.NET only ran in IIS. But since ASP.NET Core came out, it has been building up actual web servers that you can run it on. So you can continue to run it on IIS, or you can use just like the new native socket implementation that came out in 2.1. So that is just completely native, built into Windows, built into Linux, built into Mac. It uses a completely standard way of doing it. Then you have Kestrel. Kestrel is based on libuv. It's used by Node.js. So you have battle-hardened way of running your .NET Core ASP.NET Core applications. All right, now let's get into the meat of the presentation. How do we go about securing our applications? What are good default ways of doing that? So in this, we're going to take a look at some of the authentication strategies that exist in ASP.NET Core. We're going to take a look at some of the authorization strategies. So we have authentication, identifying who you are. Authorization, what can you do? And we're going to take a look at data protection. How do we make sure that our cookies are encrypted? How do we make sure that our user data is encrypted? Next thing we're going to take a look at is, in the recent times, enforcing HTTPS. We have Let's Encrypt nowadays. You should be running HTTPS on your applications. And then we're going to go over some other common attacks and how we mitigate them. So authentication. ASP.NET Core comes with a long legacy behind it. And now we have an identity framework. This framework allows us, well, I'll get into that in a bit, but this framework allows us to build on top how we want to identify users and how we want to authorize them. The other thing that we can do is we can use built-in Windows authentication. Windows authentication continues to be a standard way of doing like intranet applications or doing things that you don't really need to have interfaces with. And the next thing is we can DIY your authentication. So you can build cookie authentication, you can build token authentication, but we're mainly going to be concentrating on cookies. And the next thing that I just want to mention in brief is that all of this stuff, Microsoft has built templates for. So if you want to go and you want to find and just drop into your application, you can just Google for specific templates for single identity, multi-identity. You can just go for them and just drag and drop them into your application. So an identity framework. Identity framework is used to build complicated membership systems. It can have account management. It will do external logins. And it has the ability to do plugin persistence. So what does this mean? Oops. So what this means is that we can build a single unified representation of who are users in our application and what can they do. And we can use either our own login strategies, if we have like enterprise or we have federated identity, we can use those, or we can use like Google, Microsoft, external providers. And the best part is we can run it and store it wherever we want. Beforehand, we had more of a tight coupling to SQL Server, but nowadays we can run it on Progress, we can run it on MySQL, wherever we want a persistent, we can write that provider ourselves. So now we're going to start exposing you to some code. So what we have here is we're actually adding identity to our application, and it's actually quite simple. So we have services in our application, and what we do is we just want to add the representation of our user, and then we want to persist it using another framework called Entity Framework, which is used to persist to SQL servers, and then we want to add a default way of protecting our data, which we're going to just add the default token providers. And the best part is you can go through and actually start configuring some of the underlying bits. So for this example, we have the ability to configure how we're actually storing this on the front end. So after we have a user, we've serialized them, and we want to send them down to our actual web page, what we can do is set, hey, we want this cookie to be HTTP only. That's going to store it securely in our session. We can set when it expires. We can set where we want them to be redirected when we challenge them, access denied, and sliding. There are many other ways of setting this, but they have exposed a consistent way for any kind of application you want to build. The next thing is that we have even more configuration. So by default, you don't even have to worry about this because it'll have secure defaults, which you can just go look at the source code for. But I have posted the source code up here, so you don't have to worry. So by default, it's going to do very shallowly complicated systems. They don't want their users to be too secure or too insecure. They have to strike a balance between storing too much things and storing not enough. But basically, by default, they want to require unique emails, and they want to make sure that new users are allowed to register and things like that. So, in order to use this in our application, all we have to do is say, use the authentication. Pretty simple. But the thing to note is that before we're using authentication, we actually have static files. So the way the pipeline works is you read it from the top down. So anything before this block of code is not protected. Anything after is protected. So MVC is the framework that powers our web pages. Static files are just images, JavaScript, CSS. So anything before we're using authentication is going to go before the authentication piece. So you want to make sure that you iron out which strategies and what resources you need to protect. So the next thing is Windows authentication. So ASPNET Core has come out with two strategies for this. If you want to host it inside IIS, you can just continue to do that. It's pretty simple configuration for your project. But in addition, they have the HTTP sys. So what is HTTP sys, you might ask? That is the actual foundation of what IIS is built on. IIS, the way they engineered it is they have an HTTP handler built into IIS that's actually built into the Windows kernel. So you can just go and use that directly now, and you don't have to even host it in IIS. So that way you can run things as like Windows services and very esoteric ways of running your ASPNET Core applications. They support it. They support everything. So how do we configure HTTP sys? Well, since it's such a low level of the operating system, it requires a little bit of lower level configuration. So this is actually, every ASPNET Core begins with a main function. It's no longer having complicated setups. You have to worry about the global ASAX and all that stuff. It starts with a main.cs, or a program.cs in this case. And that has a main function. That just builds a web host, and then it runs it. It's very simple. And as part of that, it creates a default builder, which is just going to assemble the HTTP pipeline and put together all the things underneath that you can do. And then it's going to use the startup file. So the stuff that we saw back here, that's in our startup file. And then we are going to actually configure the web server. So at this point, we can actually configure the web server. So that would be HTTP sys in this case. So inside of this web server configuration, we'll just tell it, hey, we want to use Windows authentication. And then, in order to configure it, we just go into our configure services block like before, and then we just add in HTTP sys as our authentication scheme. And for IIS, it's pretty similar. You'll notice between the two slides, what has changed? HTTP sys defaults, IIS defaults. You can pretty much find anything with a defaults. Cookie defaults, tons of defaults. And now we can go into cookie authentication. All right, Dustin, I want to roll my own authentication. I got my enterprise thing that already exists. We've been using it for 20 years. We wrote it in C. We're not going to rewrite it. It's just the fact of life. All right. So cookie authentication. The best part about this is Identity Framework is built on cookies. So you don't have to worry about Microsoft not supporting this because they use it themselves. So the cookie authentication also can be used in multiple ways. You can just configure one global cookie for your application for sessions. I should say that again. You configure one cookie for your application sessions. Or you can configure multiple ways of authenticating. So you can have different cookies in your application depending upon who is in your application. You can have one cookie for Windows authentication and one cookie for Google, and then you don't have to worry about that. And the other thing that I'll mention in briefing is cookie policies. We can use this in order to enforce general defaults on cookies. So for the cookie authentication, we will see cookie authentication defaults. So as before, we added Windows authentication, but now we're just adding cookie authentication. And the only other thing that we have to do is we just have to add the cookie. That'll just add a cookie in our application. Whenever you log in, it'll just take care of it for you. But also, just like before, we get ways of configuring. There are tons of options for this, and there's tons of documentation for it, so I won't go into that. So you've probably seen this slide before, and that's because I copy-pasted it, because there's one standard model of doing this. You just need to use authentication. You don't have to use cookie authentication. You don't have to use Windows authentication. You just use authentication in your application, and whatever you have configured for it, it will just use. The next thing, authorization. So authorization could be a talk on its own because it is such a complicated topic. So for now, we're just going to go over simple authorization, but I wanted to mention to you the different kinds that are available to you. So you have simple authorization, that's just being able to configure things as protected or unprotected in your protected resources. You have role-based authorization, that's been around forever. The original versions of ASPNET included role-based authorization. We've kind of migrated though to claims authorization. Claims authorization. So claim-based authorization is just being able to say things about your user and assert that. So your user has a name of John Doe, things like that. And then new in ASP.NET Core is policy-based authorization. So that builds on top of claims. That allows us to specify policies for users. This user must be over the age of 18 to use our application, things like that. And on top of claims, we also have resources. So now you can protect resources in your system and not necessarily have to go through all the drudging of all the claim stuff. So how would we do a simple use case? So if we wanted to just authorize a controller, all we have to do is just tag it with authorize. That'll just feed into the authorization pipeline and it'll just protect it automatically. We don't have to worry about it. But we also have granularity. We can apply that to just one method in our controller or multiple methods. But there's also ways to opt out. If we want to just allow users to log into our application without being already logged into our application, we could say use the allow anonymous. And then our next topic, data protection. We want to make sure our sessions are encrypted. We want to make sure our passwords are hashed. We want to make sure that our reset tokens are secure. Now how do we do that? We use data protection. So there are different components that come in the data protection package. One of them is purpose strings. So this is more of a low-level technical detail, but what that means is that we have ways of separating our data protection into multiple layers that act independently, and I will explain that later. Now we have multiple tenants. So if your application supports multiple companies, so you have multiple companies buying from you, you can separate their data and partition it, just like that. We can also have revocable data. So that way, if loser uses access to the system, we just revoke it, they're good. We can also make their data protection expire. And if you don't like the way they're doing their crypto and you want to use some, what is that they use? Sorry, I can't remember. It's elliptic curve cryptography. If you want to use elliptic curve cryptography, you can do that. All right. So let's do a simple example. So this is my class. My class has a constructor, and it takes a data protection provider. Data protection provider is provided to us by the dependency injection system, so we don't have to worry about where that comes from. And what we do inside here is we create a protector. The protector uses a purpose string. So the purpose of this application is to just annotate some data in here. And then we just want to run it. So what we're going to do is we're going to get some secret information, and then we're going to go through and protect it. And after that, we can unprotect it and just get it back. It's pretty simple. And the way this works is that we have one key that we're using. So the data protection provider, it provides us with a master key, and what we can do is add in the purpose strings in order to create partitions of that. But keep in mind, when you're protecting your data, you don't want to necessarily create protectors that are too generic, or you can suffer from injection attacks. So if you wanted to create like secure messaging for your clients, so they would be able to encrypt their messages in their iMessage, what you would probably think is, hey, why don't I just protect based on the user? Well, then you run into the issue of what if the user just makes their username your session cookie, and then, oh, you can unencrypt everybody's session cookies. Too bad. So what you would do to mitigate that is you can use multiple values for a protector. So you can say, this is just going to be for my secure messaging application. And then in order to sanitize it, what we would do is just throw the username into a string, and that way they cannot inject it in there. And we'll go over injection later, so don't worry. So, multi-tenancy. So as we demonstrated before, we can partition the keys, but we can also partition the keys of the keys. So that means we have a flexible model of actually protecting our data across the application for multiple tenants. And how does that work? It works because when you're passing in multiple keys to the same method, it's the same thing as just partitioning it multiple times. So that way you can pass in a data protection provider to your service, and then that service can create another service with each tenant. And that way it's just segmented. Next thing we have to worry about is enforcing HTTPS in our application. HTTPS, want to make sure all of our communication is secure. So there are multiple ways of doing HTTPS, but today we're just going to be covering simple hosting a website on the internet. So what we want to make sure is that either we have all requests are just by default coming on HTTPS, or we want to make sure that we redirect insecure requests or back to HTTPS. So the simple way of just doing this is decorating your controllers with require HTTPS. Now this, keep in mind there's a caveat to this. If you are writing like API-oriented applications to where they don't necessarily have like session state and all that stuff, they might get confused by this. So the recommended approach is to just not listen on HTTP at all. Or instead, if you receive a redirect request, just close the socket. That way you don't suffer from a whole lot of attacks that come out of that. So how do we configure this? So you've seen configure services before. Configure services is pretty much how you configure everything. So what you would want to do is just go through and add HTTPS redirection. And you can add, hey, I want to do a permanent redirect, I want to do a temporary redirect, and you can actually say, hey, I want to, and my HTTPS port that I'm redirecting to is 5001. So if you have custom settings, it'll take care of that. And just like using authentication and authorization, you just have to do a simple use HTTPS redirection. So notice in this example, we are doing HTTPS redirection before the static files. So the pipeline, as I mentioned before, works in order. So if you were to say have static files and somebody requested that, you had the HTTP redirection after that, then you would get insecure files being served. So HTTP strict security transport. So this is one of the newer standards that have come out. So this is a header that you can have your web server return in order to prevent HTTP communication altogether. So Google came out with this for Chrome, and what it basically does is it prevents the browser from even attempting to make an insecure connection to your website. Now that's a double-edged sword, but we'll go through that later. So strict transport security. One of the easiest ways of doing this is to just tack on max age. So it'll just sit around and don't have to worry about it, but that does not cover subdomains. So if you have your example.com and you have applications hosted under that, you'd have to do it for each application. But if you just specify the include subdomains, it'll also do that. Another thing that you can do is you can actually add your application to the global preload list. So Google maintains a list of websites that are forced by every browser, by every installation of Chrome to go to there. So if you have like CNN.com or some guy, they're probably on the preload list, which means when you install Chrome on your computer or Edge or whatever browser you use, it will come with that list. So even before you connect to the web server, it already knows that it needs to use HTTPS to connect to it. So You want to make sure if you're using the preload option that you're really sure that you have everything configured correctly, and that you're not going to use HTTP anymore, because getting removed from the preload lists is a pain. So how do we add HTTPS to our application? So one thing to keep in mind is that when we're actually developing applications, we don't necessarily want to use this header. This header, by virtue of being a header, is very cacheable, which means unless you are completely using HTTP for your development environment, you're going to get this header, the browser's going to cache it, and then you're going to have to remove the header every time you want to refresh the page, which is not exactly what you want to do. So what you want to do is use the hosting environment. So inside the hosting environment, what you can do is say, hey, I'm a developer, I'm developing things, so I'm going to use my developer tools. Otherwise, we're probably in another environment, production for instance, and we can just stop using bad error handlers and we can use whatever our production settings are. And like before, it goes from top down. There's a top-down approach to the HTTP pipeline, and we want to make sure that we use HSTS before we do HTTP redirection, because we don't really need to, because if we don't want them to connect to us in the first place, then they shouldn't really be doing that. So how do we configure this? So just like before, we're going to use our services. Our services have options. We can make sure, so notice before we had pretty simple max age include subdomains. And now it pretty much mirrors it one for one. So if you go through the documentation on the Mozilla Development Network or wherever you get your documentation, you say, hey, I need that option, you can just go look for that option. It'll probably be there. You don't have to worry about it. CSRF, cross-site request forgery. So this is a little bit more complicated of a topic, because we actually need to worry about our authentication strategy for this one. So what CSRF is we have another application that's not necessarily doing so good intentions, and they want to abuse the fact that our users logged into a website. So what they're going to do is they're going to post to some API that the user's already logged into, and then they're just going to create a transaction and submit it over there, and now your bank account is empty. So you want to prevent that kind of stuff. But that requires a little bit of thought. You want to make sure that if you have like a same origin policy on your website, or how you're actually storing that stuff. So usually CSRF is vulnerable to like session storage. But if you're using like token-based authentication with local storage, then you might not even be vulnerable. So by default, in the ASPNET core, it's just secure by default. So if you write a form, it'll be protected. So whenever this form actually gets rendered on your web page, it'll include a hidden field with your anti-forgery token. That is pretty much the Microsoft solution to this. And there are other ways of doing it as well. But what if you want to opt out? Well, there are a couple ways to opt out. So in the Razor way of doing it is you just annotate your HTTP forms and say, hey, I don't want to be secure. That's fine. You can also use the new way of doing it that they've invented for themselves, which is just the exclamation form, which is like the danger form. I think that's what they're going for there. And another attack is the open redirect attack. So say, for instance, you have a web application, and you need to redirect to a different page, like on login or something like that. If you do not sanitize the URL that you are redirecting to, you're going to suffer an injection attack, basically. So, audience question, can you spot the vulnerability?
Log on.
Yes. So we have the nerd dinner, but then we have nerd dinner with one N. So if you're not protecting against that, and somebody just decides that they're going to register a domain that looks similar to yours, or maybe like appple.com and cash in your iTunes gift cards, yeah. So the way this works is the user clicks a link to the trusted site, and then they log in, and then sometime down the road they receive a redirect on that website, and it goes to malicious site. Then they're just going to automatically be redirected if you're not protecting yourself. So how do you protect yourself? It's actually quite simple in ASP.NET Core. They introduced local redirect. So before you just had plain redirect, which would just take whatever you passed it and just do whatever with it. It would just send you to whatever website. Now you just have local redirect, and it'll just say, hey, am I on the same domain? That's a pretty good idea that I don't redirect them. Another way is that if you just want to whitelist things, you can check URLs to make sure they're local URLs. So if you have like multiple websites under subdomains and things like that, you can make sure that you're performing redirects between applications correctly and things like that. So CSP, Content Security Policy. So this is a way of mitigating cross-site scripting. Cross-site scripting is basically you have some web server that you're serving JavaScript for, and that web server gets compromised, or you get an extra script injected because their computer's compromised, things like that. You do not want to run things that you do not originate on your website, basically. By setting content security policy, you also get the way of mitigating packet sniffing, because you can do HTTP enforcement similar to the HSTS. And the best part about CSP is the report URI. So if you have a failed attempt on your website and it violates the CSP, it'll actually report that to a URL of your choosing. So you can get feedback and say, oh boy, those anonymous hackers, they're on my website. So how do we set content security policy? So it's pretty simple. You set a header, and then you just specify the policy afterwards. There are a bunch of options. One of them is the default source. So the default source is basically all content on my website I want to originate from myself. That way, we're not going to consider CDNs, we're not going to consider anything like that. Another way is that we can configure subdomains. So if we want everything under our trusted subdomain, we can include those. But the problem is that Microsoft doesn't provide middleware for this. So what are we going to do? There's no Microsoft ordained solution. Well, there's hope. We can extend the pipeline. And how do we do that? We can just use our own middleware. We can just write directly to the response headers if we want, or we can do even fancier things to configure it. We could build our own API for doing this. It's pretty simple, and it works exactly the same way as we've seen before, where you're adding authentication. So everything goes from the top to the bottom. So your CSP will get set before you're using static files and everything. So that way, we're all serving from ourselves. All right, time to have some fun and check out some vulnerabilities. So the OWASP organization, they started a while ago, but they started publishing in 2013, I believe, and they published a top 10 list of the most industry issues, one of which is injection, which has basically been on there since its inception. But there are a lot of different vulnerabilities that happen in your applications, and we're going to go over just a few of them. So in this presentation, we're going to be covering injection, which is pretty common as we've seen. We're going to take a look at the broken authentication and what we can do to fix that, and then we're going to go over some XXE. We'll get to that. So what is injection? As we've seen before, if we use unsanitized or untrusted data and we just try to do things with it, it usually doesn't go well for us. So if we end up having like unsandboxed execution of something that our user gives us, we're usually going to be vulnerable. Or if we have like broken versions of interpreters like XML, things like that, and we can inject in there and fix it, there's a whole lot of variants of injection. But can you spot the issue with this? SQL injection. So we're just taking the user's ID that they're passing to us and we're just concatenating it to a SQL string. I mean, what could go wrong with that? But there's also different forms of injection. So you may not necessarily be passing it directly. You could be passing it by indirection. Somewhere earlier in your application, you're concatenating some SQL string, and somewhere the user ID gets concatenated, and oh boy, things happen. So how do we fix vulnerabilities like this? Well, the common way of doing it is that we either use a built-in API in order to escape it, like for SQL injection. The actual SQL server will prevent the injection for us. But there are other ways of doing it, like appending data or things like that. So another vulnerability that is related to injection is called overposting. So for instance, if we give an application more information than it's asking for, and it doesn't do, and it just accepts our input without knowing, then bad things can happen. So in this case, we have a model that we're just sending to our web server that's saying, hey, John Doe, and is he a super user? But the thing is that we're just taking that model and we're using it. And by doing that, we're exposing ourselves to, hey, John Doe can be a super user whenever he wants. So how do we protect against this? Well, in ASP.NET, you could just use the bind attribute. There are a whole host of ways of doing it. So the bind attribute just basically says, I only want to take this property off of this model. That's a pretty simple way of doing it. Another way that they introduced in ASP.NET Core is that you can just use annotations. We're pretty used to using annotations in ASP.NET. One of the annotations that we can use is by never. That way we can just specify the properties that we do not want. Another thing that we can do that we've been doing for forever is just use copying. So we can just take a model and then just create a safe copy of that we can use later. It's just the design pattern. And another thing that we can actually do is just split our model. Why are we subjecting ourselves to this pain in the first place? We can have a model for just sending to the server, and then we can have just a generic model that we use everywhere else. And that way, we're just never vulnerable in the first place. All right, let's talk about broken authentication. So authentication requires some thinking. We have bots nowadays. Bots like to attack things. If you're not rate limiting your APIs, you're probably going to be vulnerable. If you have weak passwords that you're allowing your users to have, if you're not setting them up like I showed earlier, then you're going to be vulnerable. If you have weak passwords combined with single factor, you're not using multi-factor, then you're going to run into password 123 as somebody's password, and then that's on the top 1,000 list of generic passwords, and then that bot is going to automatically attack your site because he's not rate limited, and you just have cascading failures. Another thing is exposing session IDs. If you have been reading the news lately, AT&T, you could just go look at anybody's bill because you could just increment an ID in a URL and boom, you could view the next guy's bill. So one way of getting around broken authentication is not to do authentication in the first place. We've seen some strategies for implementing authentication. We can use Identity Framework, or we can use a bunch of open source solutions that have come out. ASOS. ASOS is an actual framework for building things like Identity Framework. You can build your own OpenID provider, and OpenEdict is actually built on top of it. Another thing that you can do is use just a commercial off-the-shelf product. So like Identity Server. Identity Server is an open source and commercial solution that you can just go download, run on your own web server. Don't have to worry about it. Or you can use something like Cierge. Cierge is a passwordless drop-in solution. So it won't store any user's passwords, and it mainly uses like Google authentication, Microsoft, and it'll just pass you a token back to represent your stuff. Another thing is to just use the various identity workflows that we saw earlier. We can use individual, we can use Windows, or we can use the drop-in identity provider. So we can use something like Active Directory or something like Amazon's identity solution. All right, the next thing that we're going to talk about is a more fun thing that I picked. So XML external entities. So basically, if your application accepts XML and it goes through an XML parser, that is not the default one, or it uses some other kind of XML from a third party like SOAP or SAML or some industry standard XML like MISMO. MISMO is one of them. Then you may be vulnerable. But the good news is that you're not. If you're using ASP.NET Core, it's not vulnerable. And that is because it is not vulnerable by the fact that it uses .NET Standard 2. And .NET Standard 2 is implemented on Framework 4.6. And Framework 4.6 is not vulnerable. Yay. But ASP.NET, if you've got legacy code bases, which I'm sure Mike Dennis has, then you're going to probably want to listen in on this part. The good news is that if you have a version at 4.5.2 or above, you are safe because Microsoft actually fixed their issues. But you are not going to have a good time otherwise. But the good thing is if you just use linked XML in your application, you are safe. If you use XML dictionary reader in your application, you're safe. But, yes sir, time, cool. But if you're using XML document, so XML document is an API that is pretty much as old as .NET, you're not going to be safe. So this is a demonstration of an XML extensible entity attack. And how it works is that you just embed the entity into your XML, and then you can just say, hey, I want to load a file. So it's nice that I can just arbitrarily load a file into my XML document, and then I can just write that out somewhere, and a hacker can get my credentials. That's nice. So the way you fix that is by the XML resolver. So if you set that to null, then you will be good because it just won't resolve any entities. It's going to be a common train with all these threats. Is that back in the day, Microsoft was like, well, why don't we just do everything by default, and then nothing's going to be vulnerable from that. But XML node reader, that's safe. XML reader, it's another common thing that we use in order to read and write XML. That's safe. XML text reader, that is not safe. So for XML text reader, we actually have to prohibit the behavior just like we ran into with XML document. It's pretty simple. But it's vulnerable in multiple ways, because prior to .NET Framework 4, which is, if you've written software in the last 6 years, yeah, you're probably not using .NET 4 unless you're Mike Dennis. But yeah.
He is like 4.6 something. So.
Oh, good. I'm sorry for picking on you. All right. Prior to .NET Framework 5.2, you would have to do this. So this is a cascading effect, and the fact that both of these properties exist, except Microsoft was like, hey, maybe we should just add a different kind of processing to this thing. So, but we're going to have the same vulnerability. We just made ourselves vulnerable twice. And XPath Navigator is unsafe, but that's only by virtue of the fact that XPath Navigator uses unsafe things like XML Reader, which means if you're using XML Reader, you will be unsafe in certain circumstances. And XSL, so XML style sheets. I don't really know who uses those anymore, but it suffers the same kind of vulnerability as the XPath Navigator because it uses the same underlying thing. And that is my presentation. It's kind of random at the end, but those are just some things that I've learned. If you want to learn more about ASP.NET Core, you can check out their GitHub. And there's great documentation too. I consulted that a lot when I was writing this presentation. And if you want to remember how to host things, ASP.NET Core Anywhere, you can just read Scott Hanselman's GoDaddy hosting post. Otherwise, here's some people that I follow in the community about ASP.NET Core security. So there's Barry Dorrans. Barry Dorrans actually works on the Microsoft team, and he basically posts all the CVEs on GitHub. So he speaks a lot too, so he has a lot of presentations recorded. Some of the community members are Brock Allen and Dominic Bayer. So those guys actually wrote Identity Server and contributed it to the open source .NET Foundation, which basically is the parent organization for .NET now. And then you have Troy Hunt, haveibeenpwned.com. He's the guy who's been basically slurping up passwords for all these breaches, and he also writes a lot of .NET. So that's my presentation. Are there any questions? All right, I'm done. Thank you.